All right, everyone, thanks for joining us on the latest episode of the Electrify News Podcast. I'm your host, Joe Borrás, and with me today is Cory Steuben, the president of Lean Design, which, for those of you who are kind of internet car guys, you probably know of Lean Design as Sandy Munro's company. They're the guys that, they bring the Teslas and the Jeeps and all the Faraday Future, all the different vehicles onto their website. They do a teardown, they compare and contrast these different vehicles, and they have really kind of come into their own over the last couple of years as like the experts in how EVs tick, how they're put together, and really how they're built. Cory, thanks so much for being on the show this morning.
Yeah, thanks for having me. Let's jump right into it.
Yeah, absolutely. We were talking a little bit before the show, about Sandy's history and Munro's Lean Design's history with Teslas, going from years ago saying like they're built like 90s Kias to really in recent years, coming out as I don't want to say proponents, but you've really come to admire and respect what these guys are doing in comparison to other OEMs. Can you talk a little bit about what makes Tesla specifically different from some of the legacy car makers in terms of manufacturing?
Yeah. So Munro Associates, we have the luxury of a 35-year history, and we come to the EV analysis with a ton of context. So we've torn down well over 200 vehicles over the past 35 years. I personally have seen hundreds of internal combustion engine vehicles completely disassembled over the course of the past, 12 years. So as we moved into analyzing the electric vehicle space, it was clear that some of the traditional OEMs were using the same supplier bases, the same methodologies and corporate structures to build their electric vehicles. But then when we saw Tesla come out, not the Model S and Model X, when they came out with the Model 3, there was a huge step change in how the vehicle was designed. The elegance with which they designed the thermal system was what really struck me, because when we removed the frunk, I saw at the time what was called the super bottle, and they integrated both of the electric fluid pumps into the bottle and the valve and the chiller and the level sensors. So they took one component that was traditionally about 15 and combined them all. And what that did was, you may say, well, how does that value the customer? It's actually more expensive to design a super complicated thermal system. But what that did was, the advantage is now you have less distance in lines for the thermal system. The pumps don't have to work as hard because there's less bends and less fluid. The amount of energy you need to put into the fluid to heat it up or cool it down is lowered because there's less of it. And as we started comparing and contrasting Tesla's thermal system to the Mach-E, to the Chevy Bolt, to the BMW i3, it was about 66% less parts and weight. So when the MPGE numbers came out, when you see Teslas being so much more efficient with a such smaller battery, so they have about a 75, 78 kilowatt hour battery, yet they're getting 300-mile range. Jaguar I-Pace, 90 kilowatt hour battery, 200-mile range. It's almost like death by 1,000 cuts. We were seeing the OEMs dying by 1,000 inefficiency cuts. And Tesla just it was a huge paradigm shift in how vehicles are designed. And now we see a lot of OEMs playing catch up. Now, Tesla launched that vehicle in late 2017, 2018. So it'll be real interesting to see what Elon announces at Investor Day coming up on March 1st.
Well, we talk a lot about complexities and the complexity of design whenever you're designing a product. So my background comes from motorsports, and a lot of that same idea of anything that you can get out of the car to save weight, any place that you can get one component to do two jobs and increase efficiency. It does, it's efficiency for another reason, right? We're trying to make things lighter so that they go faster and that kind of thing. From the point of view of a customer, I understand the range increase. I understand that additional efficiency equals more driving range for when you're on that long road trip. But when you're talking about a car that's in the secondhand market, which a lot of these early 2018, 2019 cars, they're coming off lease, they're being bought, they're being traded, and you're a customer buying that vehicle, is a part like the super bottle prohibitively expensive to repair or replace once you do come to that point? Because it seems to me, And I think probably to a lot of people that the question is, well, if it's just a standard valve or something that's from another kind of legacy supplier, should be readily available and easy to repair and maintain.
Yeah, it could cause a slight increase in serviceability, but I'll use that specific example. So to access the super bottle, excuse me one second.
Yeah, no worries.
Yeah, to access the super bottle, you just remove the frunk and the cowl trim, and it's right there. And then you'd have to drain the fluid, which you would have to on a normal vehicle. And then to replace the pump is 4 bolts into the side of it. So you pull it out and replace it. The valve is stuck in the bottom. So yeah, they may hit you with Tesla may hit you with wanting to replace the whole entire unit, which would be expensive. And one thing that's really interesting about Tesla, and I say this a lot, they chose reliability over serviceability. Now, this doesn't mean the vehicle is more reliable than other cars. They chose to prioritize the reliability of the design that they designed. You can see that in the battery. So with the new 4680 pack, if they have one cell go bad, that whole pack is useless. The entire thing. You have to scrap it. There is no way to service one 4680 cell. You look at a BMW i3 with that 22 kilowatt hour pack launched in 2014 or 15. You have one cell go bad, you can remove the pack easily. You can easily remove the cover. When you remove the cover, all the lines are color coded in orange, the high voltage ones. You can put some gloves on, you can unplug them. 4 bolts, you can take one whole module out. They even have a plastic cover covering the contactors where all the batteries are connected together so you don't electrocute yourself. So that BMW i3 is carrying $50 to $100 worth of totally unnecessary color-coded cables and cords and protectors for that one service technician that might eventually service it. So many vehicles carry all sorts of ancillary componentry to protect the safety of employees during assembly if it's not automated, and then the safety of service technicians for midlife to end of life servicing. And that's why when you see the lid of a 4680 Tesla pack glued on with that pink hard foam, if you haven't seen it, we did a teardown of that entire pack.
It was a good show.
Yeah, nearly impossible to remove. I mean, no serviceability whatsoever. But when you glue everything together and you don't have threaded fasteners, your reliability actually goes up. One of the biggest indicators in a low quality design is however many threaded fasteners you have, because threaded fasteners are the number one root cause of a service issue or failure.
So that's interesting, because that's not something that I think I've never heard that statement about the threaded fasteners being the number one source of failure. So when you talk about even in a legacy vehicle, right? Like whenever you talk about something going bad, like, I'm on an AMG kick these days. So there's a C63 AMG. That was a car that came out in 2008. It was a big motor and a little sedan. Mercedes-Benz put this out there, and these cars were kind of famous for having bad head bolts that would stretch and expand over time because the metallurgy wasn't quite right. They would warp, they would loosen, coolant would get into the cylinders. It would be a massive nightmare to repair these things, and it would be, tens of thousands of dollars on a car that probably changes hands these days around 15, 20 grand.
Yeah.
So this is the kind of thing that, like, you guys being the experts in what you do are seeing that. How do you convince someone who is kind of a shade tree mechanic or a 100,000, 150,000 mile person that these design choices, whether they're from Tesla or anyone else, are genuinely more reliable, when in the past we've kind of all been taught, like, hey, if it's easy to fix, that means you can keep it on the road longer.
Yeah. So the reliability topic with EVs is interesting. And I actually like to take it up a level to the theoretical side with thermodynamics. So think of the energy in a gallon of gasoline or a gallon of diesel fuel. The majority of it is wasted in what? Heat and vibration. A very small percentage of it is used for forward locomotion. I think diesel engines are at best 30 to 40% efficient, and gasoline engines are even less. And then once you actually get through parasitic losses in the driveline, and then drag from your coefficient of drag, rolling resistance, you're looking
And
at
that's when
like,
it's moving. You're not even counting traffic,
yeah,
stoplights, stop signs. Yeah.
yeah. So now going back to reliability and serviceability. So if you're servicing a vehicle, I drove a Yukon that had 250,000 miles on it. These are the things I serviced all the time. I replaced the O2 sensor. I did a cam position sensor. I had to change the oil all the time. I had to do transmission service. I had oil leaks. I had all sorts of problems, but they're all mostly powertrain related. I had a fuel pump fail. So most of your service items are related to components that are subject to a lot of heat and vibration or constant duty cycle use. Or they'll get, like I had a throttle body sensor fail because that throttle body is moving all the time. Now, if you compare an electric vehicle to an internal combustion engine, the majority, the battery is massive and it stores a relatively small amount of energy. So 100 kilowatt hours is like 3 gallons of diesel fuel. Think about it. And 100 kilowatt hours is a huge pack. It costs like $14,000. But the majority of that is used for forward locomotion because almost none of it is lost. Very small amount is lost to heat. There's almost none lost to vibration and almost none lost to noise. So, and the amount of heat that's generated is very, very carefully captured and stored in heat pump systems or used elsewhere. Unlike an internal combustion engine where
In a Tesla. In
yeah,
a Tesla. Like there are, I don't want to pick on anybody, but there are other EVs that like don't really have awesome thermal management.
that is correct. And the thermal management system I'll get into. I was just going to get into the advantage of internal combustion engines. So you have all this heat loss with internal combustion engines, and capturing only a small percentage of that to heat the cabin in the winter is an advantage. And that's why when people compare and contrast, like, man, my EV is horrible in the winter, it's because you have to use energy that you want to use for forward locomotion to heat the cabin. PTC heaters are not efficient. Heat pumps are slightly more efficient if the systems are designed correctly. I think VW designed a system that was not very good. It was almost on par with their PTC heater. They even had, like, I think, people angry and suing them. And so the point I'm making is an electric motor has, if you count the rotor moves, that's it. And if you count the ball bearings, so if you have 2 ball bearings, one on each end, and if you count all the ball bearings in the driveline, you have about 7 balls per bearing, and you might have 10 bearings. So you might have 80 moving parts, counting the little balls rolling in the ball bearing. And I count those and the cages that hold the ball bearings. So you have so few moving parts, and they all move in a circular, non-vibration motion. What that means is the things that are going to fail on an EV are going to be a poorly designed thermal system because they're taxed really hard, or your high voltage electronics late in life. So your MOSFETs and IGBTs that convert from DC to AC to drive, you may have real late in life failures of inverters and DC to DC converters. So your question was a shade tree mechanic. What are they going to think about
That's
this?
a tough one this early in the morning.
Yeah. It's just going to be a different world for vehicles, because I don't want to talk about the other parts of the car that don't really change: suspension, interior seats, windows, glass, all that stuff. Yeah,
that's all going to be fairly similar.
Door modules fail. That has nothing to do with EV versus non-EV. And then I think getting into battery pack servicing is something that you're going to have bona fide refurbishers do. You do not want a shade tree mechanic opening up a battery pack trying to balance cells.
Now, that's kind of brings up a question that we've pondered often on this show, is the question of the structural battery, where Tesla talks about using a structural battery in the most recent Model Ys, but in the strictest sense, I mean, you can replace that battery if you need to.
Oh yeah.
And then you start looking at, like, some of the concept cars coming out from Lotus and Nissan that claim to be using, if you can say that anything that's just exists purely in CGI is something that exists, right?
Yeah.
That are using fully structural batteries that are like integrated into like the backbone chassis. Is that adding to reliability in the same sense that you're talking about, or are we still talking about kind of because they are legacy brands that they may not be looking at it the right way?
So whether or not the battery is structural has, I'd say, very little bearing on reliability, and even almost serviceability. Is maybe slightly more serviceable if it's disassociated from the vehicle. But where it really helps is efficiency of design. So if you look at Tesla, look at a Model 3 and a Model Y, the early ones, they had a floor pan,
Mhm.
which the seats sat on. They had cross members, which the seats bolted to. And then they had a cover on the battery that was mere millimeters under that. So they had two large flat surfaces, one of steel and I think one of aluminum, right next to each other. So it's like all they did was move the battery up a little bit, made the cover of the battery steel, put the cross member structures into the cover of the battery, bolted the seats to the cover of the battery. It makes sense. But the form factor of the cell also grew. They went from 2170s to 4680s, and the batteries actually filled a higher portion of the battery. So we studied this, all those changes. So that's Tesla. But other OEMs have batteries that contribute tremendously to structure and others that don't. And I don't want to get into the specifics. It's not my area of strength. But when we initially got a couple EVs, the torsional mode of the body is really important. You want it to be stiff. The stiffer the body, just like in auto racing, the stiffer the chassis of the body, the easier it is to tune your suspension. If your body is unpredictable and flexes all over, then it's very hard to tune the vehicle for comfort, ride, drive, durability, all sorts of stuff. So when we first got a Tesla, we actually sent the Model 3 out to be tested, torsional tested. We torsional tested with and without the battery. And the torsional stiffness was the same with and without the battery. Local stiffness, like stiffness in the floorboard and other areas, was dramatically worse without the battery because the battery tied in a bunch of connection points. But we were really surprised essentially that the mass of the battery has a negative effect on the structure of the vehicle, because now you have to hold that mass, and the mass contributes to the model. So the structure added to the Model 3 only offset the negative contribution of the mass of the battery. So it was like it wasn't a net positive. And I don't know if I lost you there. Like, so
No. I totally get it. Like, you're whatever strength you got from the triangulation of different points by bolting the battery in merely served to offset the additional
mass
flex loads of the mass of the
correct.
battery.
Yep.
100%.
Yeah.
So let me ask this question a little bit differently. Conventional automotive wisdom used to be years and years and years and years ago that body on frame, you would beef up the frame, bigger, heavier frame rails, you'd put a body on top of it, bolted on. We then kind of transitioned to a unibody that followed motorsports in terms of very similar, that we wanted something a little stiffer after Formula One and sports car racing moved over to monocoque chassis. Automotive went to like unibodies and pressed steel. And now we're starting to see this emergence of casting, and we're having large pieces of the vehicle cast, and that seems to be becoming a bigger and bigger trend, specifically at Tesla, but you're starting to see some other customers for these Italian companies that make these giant casting machines. Are you seeing that again, and as something that's contributing to that kind of next level of chassis stiffness, of engineering rigidity, or are you looking at it as something that's primarily a cost-cutting move?
It does have a huge benefit to stiffness. Castings are stiffer, especially way stiffer than an amalgamation of thin stamped steel or aluminum pieces, welded together or bonded together. So positive benefit to stiffness, but the biggest benefit is to your ability to manufacture at a high rate of speed and shrinking your body shops. This is a huge advantage to a startup. So think of Tesla building.
And when we say body shop, I don't mean to cut you off. When we say body shop, we're not talking about like a body repair shop.
Oh, no.
We're talking about the amount of floor space a manufacturer
In the
requires
plant
to assemble a vehicle body.
Yeah,
Exactly.
sorry, that's OEM lingo. A body shop is at the plant. So traditional OEMs have really refined the ability to manufacture at high volumes stamped steel unibodies, just like you said. They're low cost. The tooling is relatively cheap if you have high volumes. The problem is that a lot of these EVs are entering the market at medium to low volumes. So usually you wouldn't use these castings in high volume lines because the casting process was typically very slow and typically relatively small. So you would have mixed material bodies by, let's say, Cadillac and BMW would often have aluminum shock towers. If you've ever opened the hood of a mediumly expensive vehicle, you could have a large shock tower that was aluminum because they could get a lot of stiffness. When you want stiffness, you want it in the shock tower. So they were adding these large shock towers, or like even the wheel inner in the rear. But the advantage of actually growing it to these 6,000 and 9,000 ton ones is the castings get large enough to span the whole width of the car, which we hadn't seen done before. We'd seen some components like cradles have the back half of the cradle was all casting, but Tesla really pushed the boundaries using Hydra because they wouldn't take no for an answer. And now we have a 2022 Model Y with the Giga casting in the front and the rear. It's our most popular thing that people come and see. They can't believe it. They're just
Is that the one that you compared to the 2020?
Mm-hmm.
You did the comparison of the 2020 California versus the 20 in Texas.
It's just absolutely wild how big it is. And, I'm trying to circle back to answer your question.
Don't even answer it. Just keep going down the rabbit hole. I'm happy.
It's not a cost advantage unless you factor in total accounted cost. So that is, if you're building a new plant and you have this huge casting in the front and the rear, now you put in, 4 or 5 Hydra giga presses, and you shrink the plant by 50% now. So you're also able to more carefully control the assembly of the vehicle because you have a casting in the front, you have a casting in the rear, you have body side outer on the left, body side outer on the right, a couple rails across, and then a few other pieces. The amount of parts in the body drops dramatically because your core components are 1, 2, 3, 4, 5, 6. So body side inner, body side outer, rear casting, front casting, body side out. I mean, it's incredible that that's the majority of the car. And then you're only controlling.
Do you think?
Yeah, go ahead.
Yeah, sorry. One of the early criticisms, or I should say, one of the ongoing criticisms, especially of the Model S, which I understand is a previous regime of thought, right, has been this question of panel gaps, of sealing, of inconsistencies. That seems to be happening less and less as they've reduced the number of body panels and gone more towards this casting process. And one of the things you mentioned Investor Day that's coming up in a couple of days here, they've been talking about Project Highland, which obviously none of us really knows anything. We can speculate. One of the things that I've brought up has been, I think they're going to go to like a single piece front fascia that's fenders and bumper, just to eliminate that kind of panel gap and eliminate that criticism. And I see that with Tesla, where anywhere they do have a legitimate criticism, they address it in a very radical way, where a conventional legacy automaker might say, well, we'll just get better at lining things up. They'll say, why do we need things that line up? We can just make one thing. When you hear about Tesla and the rumors surrounding ways that they're going to cut costs even further and make the interior less expensive to build, You might be thinking very differently. I hear that as a layperson and I go, they're going to make this thing cheaper. They're going to take stuff out of it. They're going to decontent it, because
Mm.
that's how I've been trained for the last 30 years in this business. But you might be looking at it very differently. They may actually be adding features, but manufacturing costs will be going down because of these innovations that allow you, as you said, to reduce the size of the manufacturing facility by,
Mm.
40, 50%.
Yeah, I think that Project Highland will be more about their ability to scale in the next 2 to 4 years. And in order to scale, they need a lot more plants. And if for their ability to scale, they need to continue to refine the manufacturing process. And it's more about what you can't see. I don't think there's going to be a big decontenting phase, because Teslas are already relatively decontented. If you get in them, they have the big screen. They don't have a lot of buttons. I've driven 2 road trips for 11,000 miles in a Plaid and a Model 3, and essentially you have seats, a steering wheel, and at least the Plaid had a cluster. So I don't think there'll be decontenting. No way. I think it'll be in things that the customer cannot see. So I never thought there'd be a point in time where there'd be millions of people interested in things that don't matter to the consumer. So when you get in a vehicle, does whether your whole body is stamped steel, stamped aluminum, castings, carbon fiber, it doesn't matter to the majority of the people in the world. But it matters to me, it matters to our organization, it matters to your viewers, your listeners, because it's what allows organizations like Tesla to even sell the vehicle. Because the way traditional OEMs design and build electric vehicles, at best, they're barely breaking even. They're just not. And you have to be agile and aggressive in all aspects of the vehicle in order to build it with the ability to still sell it as a profit. Because adding that $12,000 to $20,000 lithium ion battery to a vehicle wipes out the traditional business model that Ford, GM, VW, Toyota have relied on for years. And I saw this really great chart by the Visual Capitalist, just came out like a week ago, where it showed fuel efficiency technology. And the first one was like, what percentage of their fleet used cylinder deactivation? And it had the percentages of like VW, GM, Stellantis, all the way down. And then it was direct inject. Who uses turbochargers? Who uses start stop? Who uses this and that? And it went through all these fuel efficiency technologies. And the last column was PHEV and EV. And Tesla was down there, and it was 100% PHEV and EV, because they're 100% EV. And the most, it was all 1%, 2%, 1%, 0, 1%, 3%, 4%, 4%, 1%. You can still see all the other OEMs are still so far away from a fleet of 100% EV because the business model isn't there yet. So I truly think that Project Highland will be like double and tripling down to getting them to even higher scale, higher margin. But I don't think they're gonna sacrifice for the consumer. And if I see a one piece fascia and fenders, I will buy you a steak when we're in California.
I appreciate that, but I'm Earth's fattest vegetarian, so I'll just take a couple of cheese plates.
Yeah, sorry. Yeah.
No, no worries. No, you're looking at the visual. The visual doesn't line up. I hear you. But I have to ask, when you talk about these big castings and we talk about some of the advantages and disadvantages of whether it's body on frame or unibody, one of the advantages to someone like me who doesn't really know what they're talking about when it comes to castings seems to be that you can't quickly or efficiently reskin the vehicle, right? Like you can't make it look dramatically different. And I think that, and this is just my opinion, I've said this in other places, so I don't think I'm surprising anybody. I think Tesla is going to start running into a decreasing demand simply because the car looks the same. And that historically, a reskin, a refresh of the product has always kind of goosed sales numbers a little bit. And I think they're going to start to see that if they haven't already started seeing it. Do you think that that is, and this is an opinion thing, and I get that we're kind of outside of the scope of what you do
Mhm.
at Lean Design and what Lean Design even does, but do you think that that is a changing consumer that doesn't really look at vehicles in the same way that enthusiasts have for the last couple of decades, and they're really looking at them more from an appliance and a mobility as a service perspective, that this sameness of body year after year might not be a disadvantage?
So this is one topic I really love, because for all the disadvantages you just highlighted of it looking the same. So if you buy a 2018 Model 3 or you buy one now, the only real difference on the outside is that the trim around the windows is, instead of it being chrome, it's that
It's
black
black,
color.
yeah.
That's the only differentiating factor right there. I love it. And this is the reason why. Um, I think 7 to 10 years is the appropriate time to have a model design run its course. And some traditional OEMs, like, once again, I had a Yukon. If you buy a 2007 Yukon or a 2014 Yukon, they look the same. 7-year run. So a lot of the large SUVs and trucks. But beyond a refresh of what it looks like, you have trim levels, which Tesla doesn't have. It is a huge savings. So if you go buy a Honda or a Toyota or a GM product or a Chrysler product, you have the
Yeah.
low trim level, cloth seats, the LX or the LS, whatever they call it. And it's badged LS, LX, and it has decontented trim around the windows. It doesn't have a crazy grille. It might even have a different fascia. It has decontented headlights. The mirrors are different. Everything's different. So you may go, oh, well, they're making a lot of money on it. Yes, they are. But now, if you're making 250,000, whatever, Camrys a year, and you sell 40,000 of the low one, and then you sell 40,000 of the next one, and then 40,000 of the next one, and the next one, and then you have a Lexus version, which is essentially the same thing, rebadged.
Yeah.
You end up having 10 to 12 variants. And then you mix in colors. So now you have all these different colors. And then you let the customer choose different custom packages, like off-road package or like, I don't know, sport package.
Yeah. Cold weather package, tech
Yeah.
package, whatever it is.
What a traditional OEM has done is they're trying to sell to everybody. But what you do is you put an undue burden of complexity at the manufacturing plant that makes it much more complicated to build. You need more line side kitting. So now you got somebody assembling instrument panels for that Camry. Oh, here comes one. Oh, this is the low end one. So he's got to grab a different set of tools because it doesn't have the same wire harnesses. And it opens up the opportunity for errors in your build process. And the more complexity you have, you may be serving all your customers, but what you're not serving is streamlining your ability to build quickly. And the best example of that, I always go back to Tesla because they're leading this EV revolution, although Mary Barra would argue that she is. But anyways, you have every vehicle is sold with your FSD hardware, the hardware 3. And that is when we costed it out, you're looking at a $1,300 to $2,000 hit to every vehicle. And I think the take rate of people activating FSD is 14%. So that means 86% of the people driving around in a Tesla did not pay the 10 or 15, 12 or 15 grand to activate the full capability of that hardware, which means they could be driving around with a much cheaper, much smaller, lower cost computer to handle your basic lane keep assist and collision avoidance and stuff. So Tesla is giving away essentially $1 billion worth of hardware because they want their vehicles to essentially all be the same for the second owner to be able to realize that. It's like an incredible amount of money they're giving away. But then look at the benefit. When that car comes down the line, Model 3 or Model Y What are they installing? The exact same thing every time. And Tesla's ability to create repeatable processes in their manufacturing environment, it's the highest I've ever seen. And I've never actually been in their plant. It's based on assessing the actual hardware of their vehicle, how common it is across Model 3 to Model Y. And that's why they're able to scale up so quickly, is because they're not dealing with 15 colors, 6 different brands, off-road packages, all sorts of crazy stuff. It's pretty much all software defined. And then if you get the all-wheel drive, rear-wheel drive, or the big or small battery pack, those are minor changes to the build process.
That's so funny. Like we're talking about this, and in the realm of manufacturing and automotive, there's, I think, a lot to be said for this repeatability, right? But if we were to change the context just a little bit and talk about it in terms of like burgers, the argument would basically be that, like, man, McDonald's has this figured out. If you know what I mean? Like, this hamburger the same every time. And I'm sure that there's a ton of like engineers and business professors and everybody else who would say like, yeah, that's the way to do it. But I think that, you have that other group that would say, yeah, but you want that that hands-on, hand-built kind of craftsmanship. And I guess for those people, they can buy a Rolls Royce or a Bentley.
Correct. Yeah, and the Model S's and X's struggled with fit and finish because their volumes are so much lower. If you want a high-quality vehicle that has perfect gaps, buy a Toyota or a Honda, because they've been refining that forever. I mean, they have that down. They build that volume. Yeah. The amount of brain power and learnings that have accumulated over time is just astonishing. So that's what Tesla got dinged for crazy early on, is because you don't have that expertise. And even how the vehicle's designed, there was some problems with the shape of the deck lid and how it all went together. And frankly, that makes it really difficult to build a high quality vehicle. So it's kind of crazy.
Yeah, I mean, nobody's ever come out and said like, man, you really want a car that you can drive every day and depend on. You need a Rolls Royce Silver Seraph, right? Like, that's not how it goes. It's always like you buy a Honda Civic or something.
Yeah.
So listen, this is all incredibly good stuff. And man, I hope we didn't go too far down the rabbit hole for a lot of the listeners, but I mean, Cory, just incredible, great stuff. There's going to be more to come, obviously, at Electrify Expo in Long Beach. Cory's going to be there. Sandy Munro's going to be there. I'm trying to convince them to tear something down while they're there, but they keep saying, no, that's impractical, but I'll keep working on them. Before we let you go, I know I'm trying to keep to a time commitment. I would talk to you all day, but I'm trying to be respectful of our time contract here. How can people kind of hear more about what you guys are doing? How can they follow along with your insights? I know obviously you have like some of like the BMW i3 teardown as like a $10 instant report from your website, that the 22 versus 20 Model Y teardown is a really interesting read for those of you that are into this kind of manufacturing stuff. But how would you advise someone you just met to kind of follow along with what you're doing?
Yeah, so we're most active on Twitter right now. So we have 3 or 4 Twitter accounts. We have mine. We have the Munro Live one. So it's @live_Munro. And then mine's my name @Cory Steuben. We also, Sandy tweets all the time too. So Twitter is where you get the most like visceral, fast-paced, behind the scenes, here's what's coming up. And then obviously the YouTube channel, Munro Live, is our YouTube channel, where we release a minimum of 3 long-form videos a week, sometimes 5 if you count the YouTube shorts. That's where you get like long, deeper videos, and you'll see our teardowns. And then our website is lean design.
And they're super interesting. Like, even if you're not an engineer, if you're just like tangentially kind of a car guy or gal, and you've been reading Road and Track or Car and Driver for a while, and you just want to learn a little bit, the Munro Live videos are phenomenal.
Yeah. Yeah. And then our website is Lean Design. We own that trademark, but our company's actually Munro and Associates. So it was nice you kept plugging Lean Design, which is our website. And I'm circling back to Twitter. So Twitter is essentially our fast-paced way to, if you follow us on Twitter, you'll hear about all our videos and whatnot. And interesting fact, I had my team look this up. So Elon follows Sandy on Twitter. Jeff Bezos follows me on Twitter. And there's only 12 people in the world that are followed by both Jeff Bezos and Elon Musk. So granted, it's our ecosystem is followed by both, but
That's
it's like
so
a weird
funny.
little fact.
No, I love that. And I really want to do like a deep dive on that, but I think I need a psychologist rather than an engineer for that one. Of like, because you would think that they're both, they both have spaceships, they both have car companies, they both have
they
like,
compete, compete
yeah,
against each other.
exactly. Yeah, exactly right. Like, oh, you follow them too? Well, I can't follow him. They go to the other guy. I think it's great stuff. Well, listen, thank you so much for being on, and obviously follow along on Spotify, Apple Podcasts, Google Podcasts, Stitcher. I'm sure SoundCloud is another one. Wherever you can get quality podcasts, and we can call that a show. Just real quick before you go, just between us girls, who do you think is closest to Tesla?
Who's closest to Tesla? Not General Motors. Not General Motors. I would say it's close between Ford and VW.
Interesting. So not one of the Chinese brands.
No. I've had a chance to see BYD, NIO, and Xiaopeng, however you pronounce it. And frankly, their EV components, besides BYD's blade battery, are not groundbreaking. The body construction of their vehicles are average or pedestrian at best. Because we spent a lot of time interfacing with some of those vehicles, whether it's on our trips overseas and whatnot. They still are at the same level of VW and Ford. And frankly, I think the Chinese market is so large that their need to go global, particularly the North American market, isn't that pressing for them. They're going to start with Europe. So everyone we talk to, they're starting with Europe first because they think Europe's further along, which I think is true for EV adoption.
I think that's fair. Yeah. And I think, frankly, Europe is a little more open to an international vehicle, where I think in the US, you still have that made in China stigma, especially people who like to type about it on their made in China PCs, right? Thanks for listening to the Electrifying News Podcast, brought to you by the creators of Electrify Expo. Be sure to catch full video episodes on YouTube and follow us on social media platforms at Electrifying News for daily clips, news, and more.